you ever wondered what the universe is made up of at its most fundamental level? For centuries, humans have been grappling with this very question, and the answer lies in the realm of the incredibly tiny. The atom. Atoms, these minute building blocks of matter, were once thought to be the smallest indivisible units of the universe. Ancient Greek philosophers like Democritus first proposed the concept of atoms, which means indivisible in Greek. For a long time, it was believed that everything around us, from the air we breathe to the stars in the sky, was made up of these tiny, indivisible particles. However, as our scientific understanding evolved, so did our perception of these tiny units. The atom was no longer seen as an indivisible entity, but a composite of even smaller particles. But it wasn't until the late 19th century that we truly began to understand the atom's complex nature, thanks to J.J. Thomson. Enter J.J. Thomson, a British scientist whose curiosity led him to the discovery of the electron. Born in 1856 in Cheetham Hill near Manchester, England, Thomson's humble beginnings did not deter his pursuit of knowledge. His keen interest in physics landed him a scholarship at Trinity College, Cambridge. Soon after, he was appointed as the head of the Cavendish Laboratory at the University of Cambridge. Thomson's fascination with the mysterious cathode rays, streams of particles observed in vacuum tubes, stirred his scientific curiosity. At the time, scientists knew little about these rays, and many believed they were just waves of light. But Thomson thought differently. He was convinced there was more to these cathode rays than meets the eye. His relentless pursuit of understanding would soon lead him to a groundbreaking discovery that would shake the scientific community. Thomson was about to challenge the very core of atomic theory. It all began with a sealed glass tube, a couple of metal plates, and a high-voltage battery. In the late 19th century, J.J. Thomson, an ambitious physicist, embarked on a series of experiments that would forever change our understanding of the atom. The setup was simple, yet revolutionary. Thomson took a glass tube and pumped out as much air as he could, leaving just a hint of gas behind. He then sealed it with two metal plates, attaching each plate to a high-voltage battery. When Thomson flipped the switch, electricity coursed through the tube, creating a glowing beam. This was known as a cathode ray, named so because it emanated from the negative electrode, or cathode. But here's where things got interesting. The cathode ray didn't behave as expected. These rays, rather than traveling in a straight line, showed a peculiar behavior. They veered towards a positive charge. In fact, they not only deflected towards the positive plate, but they also moved away from the negative one. This was a clear indication that the rays were negatively charged themselves. However, what was even more fascinating was the fact that these rays deflected even in the presence of a magnetic field. This meant that these rays were not just any ordinary light beams, but they were composed of particles that had both mass and charge. Thomson concluded that these particles, these cathode rays, were in fact a new kind of particle, hitherto unknown. He believed them to be corpuscles, or particles much smaller than the atom itself, a revolutionary concept at a time when the atom was considered the smallest indivisible unit of matter. His experiments with the cathode ray tube didn't just demonstrate the existence of these particles. They also provided the first measurements of their charge and mass, leading to the discovery of the first subatomic particle, the electron, a breakthrough that we'll delve into in the next scene. This was the first hint that atoms might be made up of even smaller particles. Thomson wasn't satisfied with just observing the effects. He wanted to understand what was causing them. This insatiable curiosity led him down a path that would change our understanding of the microscopic world forever. Thomson started with a hypothesis. He proposed that the rays he was observing in his cathode ray tube were not just light, but rather streams of particles. But how could he prove this? He turned to mathematical calculations. He calculated the ratio of the electrical charge to the mass of these particles. This was a critical step because if these were indeed particles, this ratio would be a defining characteristic, just like the weight and height of a person. Imagine for a moment, trying to determine the dimensions of a grain of sand without ever seeing it, only observing its effects. Sounds impossible, right? But Thomson, with his brilliant mind and meticulous methods, managed to do just that for these invisible particles. His calculations showed that the particles in the cathode rays had a much smaller mass and a much larger charge than anything known at the time. These particles were over 1,000 times lighter than the lightest atom, hydrogen. This was a shocking revelation. It meant that the particles were subatomic, smaller than an atom. This was contrary to the popular belief at the time, which considered atoms as the smallest indivisible units of matter. Thomson's discovery was monumental. It was the first time anyone had discovered something smaller than an atom. He had discovered a new particle, a building block of the universe. He named this particle electron, from the Greek word for amber, because of its electric properties. Thomson's discovery of the electron was more than a scientific breakthrough. It was a testament to the power of curiosity, persistence, and critical thinking. It changed our understanding of the world on a fundamental level. It taught us that the universe is full of mysteries waiting to be discovered, and that with the right tools and the right mindset, we can uncover these mysteries. And so, the electron was discovered. Thomson's discovery was revolutionary, but just how did it change our understanding of the world? Well, to say it simply, it was nothing short of groundbreaking. Thomson's identification of the electron fundamentally altered our atomic theory, upending the existing belief that atoms were the smallest indivisible particles. His discovery showed that atoms were, in fact, made up of even tinier particles, the negative electrons and the positive nucleus. This revelation was earth-shaking, leading to a paradigm shift in the scientific world, and it laid the groundwork for the development of the atomic model as we know it today. But the impact of Thomson's discovery didn't stop at atomic theory. It rippled out, touching various fields of science. Take chemistry, for instance. The recognition of electrons enabled us to understand chemical reactions at a much deeper level. It showed us that these reactions hinge on the exchange and sharing of electrons between atoms, providing the basis for the entire field of chemical bonding. The discovery of the electron also had profound implications for physics. It paved the way for quantum mechanics, a field that seeks to explain the peculiar behavior of particles at the atomic and subatomic level. Without knowledge of the electron, the development of quantum mechanics would have been impossible. Even cosmology, the study of the universe at large, was influenced by Thomson's work. The existence of electrons and their behavior under certain conditions helps us understand phenomena like black holes and cosmic radiation. Thomson's discovery, therefore, contributes to our understanding of the universe's origins and its future. In essence, Thomson's work was a key that unlocked a door to a new world of scientific exploration. It opened up new fields of study and deepened our understanding in others. It was a catalyst for scientific advancement, driving innovation and discovery across the globe. Thomson's work laid the foundation for our modern understanding of the universe. His discovery of the electron wasn't just a milestone in scientific history, it was a turning point that forever changed how we perceive the world around us. From a simple glass tube to the fundamental building blocks of the universe, Thomson's journey was truly remarkable. It started with the enigmatic atom, a puzzle waiting to be solved. Then we met J.J. Thomson, a physicist with an insatiable curiosity. He delved into the unknown with his cathode ray experiment, leading him to a profound revelation: the discovery of electrons. These tiny particles, smaller than the smallest of atoms, were a game changer. They opened up a whole new world of atomic structure and gave us a deeper understanding of the universe. The impact of Thomson's discovery was far-reaching, affecting everything from our knowledge of physics to the development of modern technology. So as we wrap up, let's take a moment to appreciate the magnitude of this discovery. This journey has shown us how curiosity and persistence can lead to groundbreaking revelations. Next time you look at the world around you, remember the tiny electrons and the man who discovered them, J.J. Thomson.